So this video is integrated 3 semester 2 final countdown number 2. So on number 33, okay, so these are dealing with systems of equations, 3 equations and 3 variables. So you want to look and decide if you want to eliminate your x's, your y's, your z's. You can really do any of them, but sometimes one is a little easier than the other. Looking at this, I'm kind of leaning towards my y's, because my y's, if I'm looking at my y's, and here, let me move this a little bit. If I'm looking at my y's, you see that I've got a positive y and a negative y. These are going to cancel automatically just by adding these two equations. Then I can multiply this one that's already negative by a 2 and add it with this one and get rid of that. So I'm going to personally eliminate my y. Okay, but it doesn't matter which one, but you want to make sure you eliminate the same both times. So I'm going to eliminate y. So again, here, let me just one. Here, I'm just going to kind of, so this is equation 1, equation 2, I'm doing a color code, equation 2, equation 3. Okay, so I'm going to take 2 and 3. So 2 is 2x minus y plus 3z is equal to 13. And 3 is x plus y plus 2z is equal to 14. And when I add those two equations together, I'm going to get a new equation. 3x, my y's cancel out, plus 5z is equal to 27. I'm going to call this one equation 4. Okay, so you've got one equation with x and z. I need to get a second equation with x and z. So I am going to take equation number 2 with equation 1. So here, let me take equation 2. And what I'm going to do to equation 2 is I am going to multiply equation 2 this time by a 2. And that's going to give me a 4x minus 2y plus 6z is equal to 26. Then I am going to take my equation 1, which I'm going to write in purple, and x plus 2y minus z equals negative 1. I'm going to add these two equations together. And when I do, I'm going to get a new equation, which is going to be 5x. My y's cancel, which is my goal, plus 5z is equal to 25. Now, normally I would divide everything by 5, but what I notice is there's a 5z here and a 5z here. So I'm actually going to keep the 5. But what I am going to do is times everything here by a negative 1. And so for my fifth equation, I'm going to have a negative 5x minus 5z equals negative 25. So now I'm going to take equation 4 and 5, and I'm going to solve that system. So let me write equation 4 again. 3x plus 5z is equal to 27. And I'm going to take my equation 5, which is negative 5x minus 5z is equal to negative 25. I'm going to add those together. And I get negative 2x. My z's cancel out is equal to 2. So I get x is equal to negative 1. I'm still not done with the system because it has an x and a z. I found my x. So I'm going to substitute it into one of the two equations. So I'm thinking I'm going to do it into the blue one. How about that? Doesn't matter. So I'm going to go 3 times negative 1 plus 5z equals 27. So I'm going to get 5z. That's a negative 3. So when I add it to the other side, I'm going to get a 30. So I get z is equal to 6. So now that I have my x and z, I'm going to take it into any of the equations 1, 2, or 3. And let's see, I'm trying to find y. So I think I'm going to do it into equation 3 because that is just plain old y. Okay. So I am going to take those and I'm going to go, oops, equation 3 is x, so that's -1 plus y plus 2 times my z, which is 6, is equal to 14. So that's going to give me a -1 plus 12. So I'm going to get 11 plus y equal 14. So my y is going to be 3. And so my answer is, as a point, -1, comma 3, comma 6. So that is going to be our answer. So number 34 is really the same type of idea as 33, except for they're asking us to find the equation of a parabola given 3 points, and we're going to have to substitute them in and come up with our system. So let's say I'm going to use my -7, comma 0. Hold on. -7, comma 0. So that, when I put it into my equation, I'm going to get 0 is equal to a times -7 squared plus b times -7 plus c. Let's see. So that is going to be 0 equals 49a minus 7b plus c. Okay, my next one, my 2, comma 27. So I'm going to have 27 is equal to a times 2 squared plus b times 2 plus c. So that's going to be 27 equals 4a plus 2b plus c. And -1, comma -18. So I'm going to get -18 equals a times -1 squared plus b times -1 plus c, which is -18 equals -a, sorry, not -a. That is going to be a minus b plus c. So I have these 3 equations, and I want to either eliminate my a's, my b's, my c's, just like I did the last problem with my y. C's are going to be the easiest one because each one of these is just a c. So what I'm going to do is I'm going to multiply one of these by a -1, and looking at it, let's say I do it with the bottom one. Okay, so let's say I do that to the bottom one. So I'm going to write it in black. Maybe, if I can get this to work. Okay. So if I multiply this one by a -1, this is going to become +18 equals -a plus b minus c. And that's what I'm going to use with everything to eliminate c. So let me get my first one. 0 equals 49a minus 7b plus c. And 18, whoops, color code. 18 is equal to -a plus b minus c. And I am going to get, when I add that, let's see, 18 is equal to 48a minus 6b. Now, looking at this, I think I could divide everything by 6, and let me do that, but sometimes maybe we want to keep it like I did with the 5 x 5z 25 on the last problem. So I'm dividing by, what was I going to do? Divide by 6. So this is going to be 8a minus b. Okay, let's see. Okay, so now I'm going to take my pink equation, which was 27 equals 4a plus 2b plus c, and use that same 18 equals -a plus b minus c. Add those up, and I am going to get, let's see, 45 is equal to 3a plus 3b. I can divide everything here by 3. So that'd be 15 is equal to a plus b. And now you'll notice that I have a negative b and a positive b. So I can add these together and eliminate those. Let me just erase that. Okay. So I'm going to solve this system. So I am just going to write my red one underneath this. So it's going to be 15 is equal to a plus b. And I'm going to get 18 is equal to 9a, which means a is equal to 2. So I got my a. Still need to find my b. Okay, so I think I'm going to put it into this red one here. So I'm going to get 15 is equal to 2 plus b. So my b is going to be 13. And now I need to find my c. So I think I'm going to put it into my original orange one. I think that'll be the easiest math. So I'm going to put it into negative 18 is equal to a, which is 2 minus b, so minus 13 plus c. So I get negative 18 is equal to negative 11 plus c. So I'm going to add 11 to both sides. And when I add 11 to both sides, I'm going to get negative 7 is equal to c. So I've got this. Now remember, we were doing this to find the equation of a parabola. So I need to write my answer as a parabola. So I'm going to go y equal a, and my a is 2, so that's going to be 2x squared. Let me make sure my y looks like a y. Okay. So y is equal to 2x squared plus 13x minus 7. And that's the equation of our parabola. Okay, on number 35, okay, this is dealing with our current stuff we've been doing. I want to get my sign by itself. So first I'm going to subtract 2. Then I'm going to divide by 4. So I'm going to get a negative 1/2. And then I want to pay attention to for all. So where is my sign, which is my y coordinate, in negative 1/2? That's going to be in quadrants 3 and 4. And it's going to be long, short. I want my y to be short. So that's going to be, sorry, this is 6. So this is going to be 7 pi 6. And it would also be over here, which is 11 pi 6. And then sometimes, depending on the distance between them, we can write one in terms of the other, but you can see the distance here is not the same as the distance this direction. So I'm going to have to write out 2 separate answers. Okay. So one answer is going to be, let me make it not so fat. One answer is going to be 7 pi 6 plus or minus 2 pi n. And the other one is going to be 11 pi 6 plus or minus 2 pi n. And those are our answers forever and ever. On 36, this one is one I'm going to factor because I have a sine squared and a sine x and a constant, okay? So I'm going to factor this. I'm going to have a sine x in front of both factors. I'm going to have a, let's see, I'm thinking a negative 3 and a positive 1 to get me the negative 2. So that means that this is going to be sine x equals 3. And this is going to be sine x equals negative 1. And we want to do it from 0 to 2 pi. Now, your sine and your cosine will never be more than 1 or less than negative 1. So this is going to be no answer. And then when we're trying to find where our sine is in negative 1, sine again is your y. It's negative 1 right here at 3 pi halves. That's our only answer. Okay, 37, we're gonna be factoring this. So when we're trying to factor this, I am going to try to find zeros, really, is what I'm going to try to do. So I'm looking at this P over Q. Well, my P are going to be all factors of -6, which are going to be plus minus 1, 2, 3, 6. My Q is 1, so that would be plus minus 1. So when I do P over Q, I'm really just going to get plus or minus 1, 2, 3, 6. Those are the ones I'm going to try. So I'm going to do synthetic division. Okay, so let's say I start with 1, 4, 1, -6. And let's say I try 1. Bring down my 1. 1 plus 1 is 1 times 1 is 1. I add it to 4, I get 5. 5 times 1 is 5. I add it to 1, I get 6. 6 times 1 is 6. I add it to -6, I get 0. So since this is a solution, okay, x equal 1 is a solution, that means the factor would have been x minus 1. So I know I have an x minus 1 as a factor. Then I have what we call this depressed polynomial, which is 1 degree less. It was 3 originally, so this is 2. X squared plus 5x plus 6. And that's factorable. That's x plus 3 times x plus 2. So I'm going to have x minus 1 times x plus 3 times x minus 2, and that is the factors of that polynomial. Okay, on 38. Okay, we're trying to simplify this now. Tangent squared x, I'm going to leave. Cotangent squared x is the reciprocal of tangent squared x. So I end up with tangent squared x over tangent squared x, which is 1. That's my answer. So when I multiply something with its reciprocal, which these are reciprocals, they make a 1. On 39, we're trying to simplify this. So what I'm going to do is I'm going to rewrite everything in terms of sines and cosines. So I'm going to keep my cosine x. My secant is going to be 1 over cosine x because it's reciprocal of cosine. My tangent is going to be sine x over cosine x. And then what I'm going to do is I am going to try to get rid of having that cosine x in my denominator of my denominator. Okay, I don't want fractions and fractions. So I'm going to be multiplying the top by cosine x and the bottom by cosine x. Okay, but let me do this officially. So on top, I'm going to have cosine x times cosine x. Okay, that's not going to undo anything. Okay, now on bottom, I'm going to have cosine x multiply with 1 over cosine x, and I'll clean that up here in a sec. And I'm going to have cosine x. I'm going to extend that. Multiply with sine x over cosine x. So again, the whole numerator was multiplied by cosine x and whole denominator. So now on the top is going to clean up to cosine squared x. On the bottom, let me get some green to cancel. That's going to become a 1. That's going to become a minus sine x. Now, this cosine squared x, here, I'm going to write it in hot pink. So this cosine squared x, remember we have this trig identity. Let me just write it here. Pythagorean identity. I'll just put ID. Okay, so we know that sine squared x plus cosine squared x equals 1, which means if I was to rewrite this for cosine squared x, that's a 1 minus sine squared x. That's what I'm going to put in place of my cosine squared x. So I'm going to have 1 minus sine squared x over 1 minus sine x. And then you want to recognize this, I always mention these, difference of two squares. So that is going to become a 1 plus sine x times a 1 minus sine x over 1 minus sine x. And again, this and this cancel out. And my final simplification is 1 plus sine x. That is what it reduces to. Okay, on 40, okay, we got a triangle. So let me just get a triangle here. Let me make it black. Okay. And I am just going to grab this hand tool just to make it so it doesn't look like, here, let me do the arrow. Let me get my mouse, sorry. I just don't want to make it look like it's an isosceles or anything here. Okay, so in this case, let's say that this is A. Let's say that this is B. Let's say that this is C. So angle A is across from side A, so that's a 2. Angle B is across from side B, so that's a 4. Angle C is across from side C, so that's a 5. And then they want us to find angle B. Now we have side, side, side. We're going to use law of cosines because I have no pair of, I don't have an angle on the side opposite that I know. If I did, I could use law of sines. So since I want to find angle B, I'm going to be using this formula. Let me just jot it down here. Cosine B is equal to A squared plus C squared, the two sides that are not across from the angle I'm looking for, minus the side across from the angle I'm looking for, over 2 times A times C. And I'm just going to plug things in. Okay, so over here, I'm going to have cosine B is equal to 2 squared plus 5 squared minus 4 squared. And sometimes what I like to do is maybe highlight or do something so that you know which is the one that is across from your angle. That's the one that needs to be the one you're minusing. Okay, the angle you're looking for, I should say. Okay, and 2 times 5. Okay, and let's see what I get for that. So I'm gonna put it in my calculator. Okay, so I'm gonna get basically 4 plus 25 minus 16 over, well, 20. 2 times 2 times 5 is 20. So I get 13 over 20. 13 over 20. Now that is what my cosine of the angle equals. I want the angle. So in order to find the angle, I'm going to do cosine inverse of both sides. So I'm going to take cosine inverse of 13 over 20. And let's see, making sure my calculator's in degrees. Okay. And so 13 over 20. And I end up with 49 point, let's say 46 degrees. So 49.46 degrees. Okay. On 41, we want to find the zeros of this. So we want to basically solve this. 0 is equal to x cubed minus 3x squared plus 2x. It is a polynomial. This is one that looks like I can factor. I can take an x out of everything. So I'm going to have an x squared minus 3x plus 2. And that, I believe, is factorable. What multiplies to 2 and adds to -3? So it'll be a -2 and a -1. So my solutions, my zeros, x equals 0, x equal 2, and x equal 1. let's see, 42. We want to calculate, so we're going to be doing this division. I personally would not do long division, I would do synthetic. And you want to put in your box what makes that 0, which is a -2. And then I'm going to take all my coefficients, 1, 0 because I don't have an x to the 4th, 1, 0 because I don't have an x squared, -2, and 6. So you got to be careful if you don't have a particular term, you need to put 0. Okay, I'm going to bring this down. So that's 1. 1 times -2 is -2. I add, I get a -2. -2 times -2 is 4. I add, I get a 5. 5 times -2 is -10. I add, I get a -10. -2 times -10 is 20. I add, I get 18. 18 times a -2 is a -36. I add and I get a -30. Okay, so when they say calculate, my remainder would be -30. They've asked that a couple of times on some of these worksheets. This one, they want us to calculate the quotient. So since I'm starting with an x to the 5th, this is going to be an x to the 4th minus 2x cubed plus 5x squared minus 10x plus 18 minus 30 over x plus 2. That's what we get when we divide. It did not go in evenly. And that's the end of this video.